Hello and welcome everybody. My name is Helene Götschel. I will talk about looking at physics from a gender studies perspective. I'm quite sure you know what physics is, but maybe you are not so familiar with gender studies. Therefore, I will give a short introduction what it means to use a gender studies perspective. Next, I will discuss what we can see when we use this gender studies perspective and look at physics. I will give you research results and some examples. The last part of my presentation will be a short summary. Gender is an interdisciplinary research field studying the meaning of gender in many fields. But what do we understand when we use the word gender? What do we mean by that? I will introduce you three distinct meanings of gender. Many people think gender is a biological fact. It is related to the body, actually not the whole body, but mostly the genitalia, and more precisely, male genitals. And this gender expresses some inner truths. So people have one out of normally two genders. They are men or women. They are male or female. When gender is understood as a biological fact, gender research analyzes, for example, the underrepresentation of women. So if you do gender research in physics, you can study the underrepresentation and the situation of women in physics. But biological findings show there's a huge variation in sex. There's diversity in sex. There are people who have like XY chromosomes, and these chromosomes develop gonads, like testes, and these testes develop hormones, male hormones, and these hormones work not in the male way in the body, so the outside of the body, the shape of the body looks very female, like a sexual phenotype of a female person. So there are people who have this intersexual, this variation, there are people who have other variations, and there are people who have genital ambiguity, there are people who have XY and XX chromosomes and other chromosomes as well, and there's a huge variation, huge combination of all these things happening. And so far we guess that maybe 1 out of 400 people has some signs of intersexuality. If you are interested in these new biological findings, have a look at Claire Ainsworth's article Sex Redefined, published in Nature in 2015. Another understanding of gender is that gender is a social category in opposite to the biological sex. People do gender in interactions. They play gender roles. They speak with soft voice, they use makeup, they care for others or not. In doing so, they become men or women or non-conforming in a binary system. With this understanding of gender as a social category, gender research explores daily social practices and behaviors. So for example, if you do gender research in physics, you can study in a physics lab how social practices and behaviors codify and manifest inclusions and exclusion, femininity and masculinity. To understand gender as a social category might be confusing at first sight when you come from a Western culture. But anthropological findings show that there, on all continents, we find cultures with the concept of 3 or even more genders, of cultures with an open and porous understanding of gender. So gender can be fluid, it can change in one person's life. And in the recent years, also, there was a lot of critique on the binary system of gender in Western countries. So, for example, students who register at State University of New York can choose from 7 gender options: man, woman, trans man, trans woman, genderqueer or gender fluid, questioning or unsure, other identity. The third and most complex meaning of gender is a social cultural power relation. If gender is not in the body and gender is not a fixed concept in society, then gender is a powerful binary social cultural concept. When people do gender, they cite and perform gender norms about masculinity, femininity, heteronormativity, and so on. In doing so, they get classified as men or women or non-conforming if they don't conform to the traditional gender norms. And if gender research has this complex understanding of gender, then gender research analyzes social constructions and cultural representations and their entanglement with power. So gender research is not so much interested in the people and their gender, but it's interested how gender norms are created and how they keep over maybe generations and generations, or how they can change, and how cultural representations change or are changeable, and how this all is related to power relations. And if you have this understanding of gender research, then you can, for example, study the image of physics as a masculine field. So gender study is an academic field of interdisciplinary research which reflects on the meaning of gender. Gender as a biological fact, gender as a social category, and gender as a social cultural power relation. Gender studies analyzes the social constructions and cultural representations of masculinity, femininity, even binary, and it analyzes how gender is used in society to structure hierarchies and orders of inclusion and exclusion. But how can we use this gender studies that was developed in social science or humanities? How can we connect this to natural science? We can look at physics from a gender studies perspective if we put physics in a broader context, similar to science studies. Science studies is an interdisciplinary research area that seeks to situate scientific expertise in broad social, historical, and philosophical contexts. It uses various methods to analyze the production, the representation, and reception of scientific knowledge, and its epistemic and semiotic role. In similar, we can step back and look at physics and look at the context of physics. And when we keep this in mind, that physics happens within a social context, then it's very easy to use a gender studies perspective. Well, now we know what a gender studies perspective is, and we want to have a closer look at physics. A lot of research is done on gender and physics, so the question is, how can we structure this research in a useful way? To look at the concepts of gender these research uses would not be so helpful, because most of the research is done in the area of gender as a biological fact, and in the recent 10-20 years research is done gender as a social category. But so far gender as a social cultural power relation, there's not so much research in this area. So maybe it's more helpful to look at the topics that are dealt with in this research. And Londa Schiebinger made a suggestion in her book Gendered Innovations in Science and Engineering that we could subdivide the field in 3 areas, and that we can study the people in physics, the image and culture of physics, and the knowledge production in physics. And I will follow her suggestion. So first of all, let's have a look at the people in physics. You can find gender in physics by looking at people doing physics. There exists a lot of research on people in physics. International statistics, for example, show that women appear to be the minority in physics in many Western industrial countries, but their low percentage is not to be taken as a biological fact. In the former Eastern Soviet countries, there was a high percentage of women in STEM fields, or today in Iran and in some Arabic countries there's a high number of women in physics. So it's not in the nature of women to be not interested in physics. This is one very interesting finding international statistics could show us. And there are a lot of biographical studies on historical and contemporary physicists. They explore the situation of women and men and non-binary persons working in the field. Some studies concentrate on biographies of individual outstanding women physicists. Other studies question the working life and conditions that women physicists encounter in academia, industry, or education. So these studies could study a whole group of women, like some girlfriends, an association, women of a special profession, and these biographical studies show a lot of the working life and conditions that women face in physics. From a gender studies perspective, you can look at the life and work of Professor of Particle Physics Mary Gaillard. From 1964 to 1981, she was a researcher at CERN, the European Centre for Nuclear Research. And in 1982, she became a professor of particle physics at the University of California in Berkeley. And when she retired in 2009 from the university, she continued to be a researcher at Lawrence Berkeley National Laboratory. She has many scientific achievements. With her team, she worked for the prediction of the charmed quark mass, the 3 jet events, and the bottom quark mass. And in addition also, she has political achievements. In 1980, she wrote a report on women in scientific careers at CERN. If you read this article, it's really touching. She organized that women from different status groups of CERN met and talked to each other and gathered some statistics. And so she found out that most of the women working at CERN, researchers at CERN, were not paid, were unpaid working at CERN, with the argument that their husbands already are paid and one income for the family is enough. This was in 1980, imagine. And also she has has more interesting findings in this report. And in 2015, she published her autobiography called A Singularly Unfeminine Profession, One Woman's Journey in Physics. Another person is Professor of Astrophysics at MIT, Nergis Mawalwala, and her position is since 2002, she's a Professor of Astrophysics, Associate Head of the Physics Department at the Massachusetts Institute of Technology. Her scientific achievements are that she works on the detection of gravitational waves in the Laser Interferometer Gravitational Wave Observatory project, and she works on the generation of squeezed quantum states of light. And in addition also she has interesting political achievements because she's an out queer person of color. For example, in 2015 she was the keynote speaker at the conference for LGBTQ students and scientists, where she argued strongly for more diversity in physical science. There are many people working in physics, and there's a lot of research on people working in physics. In addition, you will find gender by analyzing the masculine image and culture of physics. A lot of research was done on the question of the discrimination of women, but the situation could not be solved. The discrimination remained. So slowly the focus shifted from the question of women and minorities in physics to the question or the problem that physics has with women and minorities. Don't fix the women, but fix physics. And has historical, sociological and anthropological studies on physics concentrated or opened up to study the workplace cultures and the images of physics. So the hope was to find new answers to the question, what is wrong, how to improve the situation of women and minorities. And this research from historians, sociologists and anthropologists, this research gives insight into the external and internal processes that create a welcoming or chilly climate for women and minorities at the workplace, and that encourage or disencourage their careers in physics. And again, I give you 2 examples. I study with the work of anthropologist Sharon Tariq in her famous book Beam Times and Lifetimes, The World of High Energy Physicists, which she published in 1988. As an anthropologist, she was watching the culture of people doing high energy physics, a kind of experienced outsider studying the people doing physics and seeing a lot of things people from physics themselves couldn't see. In one of the chapters of the book, she explains male tales that are told during a life in physics. And she writes, in their careers, physicists journey from romantic readings of others' lives as students, through handling on mimetic tales of heroic action and quest of survival as postdoc, to becoming, as group leaders, skilled practitioners of gossip and rhetoric. And finally, as geniuses, they complete the circle by telling erotic tales about physics, tales transformed into romance for the next generation of neophytes, of students. And she gives two examples of these tales, erotic tales of geniuses. Richard Feynman, she cites. That was the beginning, and the idea seemed so obvious to me and so elegant that I fell deeply in love with it. And like falling in love with a woman, it is only possible if you do not know much about her, so you cannot see her faults. And Bertrand Richter said, writing this brief biography has made me realize what a long love affair I have had with the electron. Like most love affairs, it has its ups and downs, but for me the joys have far outweighed the frustrations. And Travik analyzes, such stories express the desire for knowing about nature, but at the same time they express the physicist's opinion about knowing and loving and their image of women. The picaresque genre, the story of Rough, excludes women as proper subjects from the story, and therefore as proper subjects from the history of physics. The second example comes from the German research project Gender Dynamiken, which a group of sociologists studied. The title translates into Gender Dynamics, Disciplinary Cultures and Research Organizations in Physics. The group did ethnographical studies observing solid-state physics, chemical physics, particle physics, and biophysics research groups at 4 universities, 4 research institutes, and 2 research clusters, huge research teams with over 150 people in Germany. The research team found gender in the observed cultures of physics. Martine Allemann, for example, in her part, found gender as an explicit topic in conversations, mostly when these conversations were about gender equality actions, and there were quite a lot talks about gender equality actions. Gender also was found in social interactions, kind of doing science as doing gender. Gender was observable in interactive settings, in team meetings, in informal chats where gender differences are made relevant. So in the more personal interactive communication, gender was made relevant. And on a third level, gender was performed in research practices. Gender was observable for the researchers via metaphors the members of the institute used for describing their activities. These metaphors were connected to masculinity or femininity in a way, so gender was performed in these research practices. A third group of gender research looks at the knowledge production in physics. The gender order can structure the description of the knowledge that is produced in physics. Studies on the knowledge production of physics shift the image of physics from an area of eternal truth and solid knowledge to an era of human endeavor and processes of solidification of scientific knowledge. So if we watch physicists doing physics and producing physics, then we see that maybe the understanding of physics that we have in school, that it's kind of objective knowledge falling down from the sky. This is not how it works, but it's really hard work. People have to endeavor and discuss and solidificate the scientific knowledge. So gender researchers explore how in these processes images of gender are constituted, how gender feeds into the description of the material world, and how epistemological concepts such as objectivity or queerness are related to gender. To look at the knowledge production in physics from a gender studies perspective is a third way to connect gender and physics. And from a physicist's perspective, I think this might be the most interesting one. But unfortunately, there's not so much research in this area. I did a historical study on the beginning of static electricity. I studied the work of William Gilbert on the magnet. Gilbert was trained as a doctor in medicine, and he was the doctor to the Queen, and he was also working for the kind of Royal Navy. It didn't have this name at the time. And he was interested on magnetism and found that the phenomenon of electricity is very similar but useless. Magnetism is important for sailing, for trade, for colonialism, as you can see in the picture of his book. And electricity is not. So he wanted to study electricity to know what is not important and what is important. And he did research for 20 years, and he described the research and the experiments he did. He made conclusions, he developed a theory. So he's one of the first person to really work in a modern way of science on electricity. In the work of William Gilbert, I found 3 ways how gender is involved in his concept of electricity. First, it's the choice of the term electron. Among many possibilities, Gilbert could have chosen for the amber stone the Greek term electron, but also the Latin term, the English term, the Iranian or Persian term that was quite popular, or even a term from another language. But he chose the Greek term, and the Greek term electron is very closely connected to the myth of Phaeton and the Heliades. That was a myth published by Ovid in his book of Metamorphoses, and this book was a bestseller at the time. So I think that the book influenced Gilbert to choose the word electron. And this myth of Phaeton and the Heliades represents feminine yearning and powerlessness. The story goes like this, that Phaeton is the son of Helios, the god of the sun. And his father doesn't know about him, so he goes to his father and says, well, I'm your son. And the father said, oh, that's nice. Tell me any wish you have and I will fulfill this wish. I'm so lucky to have you as my son. And Phaeton says, well, my wish is, like you, I want to drive the sun carriage over the sky. And Helios is shocked because he thinks Phaeton is too unskilled to drive the car, but he had promised him, given his word, so what should he do? He allowed Phaeton for 1 day to drive the car, and it happens what we expect. Phaeton couldn't do it very well. Sometimes he came too close to the earth, so everything was burning on the earth, or he went too far away, then everything was freezing on earth. And Zeus, the very high god of the Greek mythology, he said, well, I cannot longer stand it. This will bring disaster. This will kill many people on earth. I have to do something. So he killed Phaeton by letting the car fall down on the earth. So Phaeton was killed, and his sisters, the Heliads, were so sorry that they started to cry, and they couldn't stop crying, so they continued to cry, and Zeus felt very sad about these sisters, and he decided to turn them into poplar trees. But still, when the sisters were trees, they couldn't stop crying, so they continued to cry, and the amber stone, or there was running down the trees. So so this is the origin from the legend, from the Greek legend, of the word electron. So in the word really represents feminine mourning and powerlessness. Gender also is part of the argument. Gilbert stressed in his research on the difference of magnetism and electricity, because magnetism was so powerful and useful on navigation, and electricity was not. So he conceptualized magnetism in the Aristotelian tradition as a high-value masculine form in virtue, while electricity was to him a feminine, inferior and passive matter. And in addition, electricity was passive because you have to rub it first to bring the electricity out. If you have a magnet, it's always magnetic, so this is very active. But electricity is inside and you have to pull it out, so it's a passive matter. And a third area where gender is can be found, it's the theory. The matter of electricity in Gilbert's theory was an effluvium, a watery substance of subtle solution of moisture. It's a liquid that's almost not there, more a virtual liquid, and it is exhaled and sent forth by friction of the amber stone. So if you rub the amber, this effluvium, this liquid, is going out into the circles, and this can attract small particles to the amber stone. And in the tradition of ancient and medieval medicine, remember, Gilbert was a doctor of medicine, water was one of the 4 elements and represented femininity. Water, like earth, represented femininity. The concept of effluvium dominated physics for more than 200 years. And in the next century, when there was the beginning of research on electricity, and it was found useful to have electricity, suddenly male elements were used to describe it. So it was fire, not longer water, as the element to describe electricity. Maybe it's easier to find in historical cases, or to understand in historical cases, how gender and physics are entangled. But also you can look at more recent examples. Look at the names in particle physics. We have research institutes like CERN and DAISY, Fermilab, accelerators, LHC, SPEAR, Hera, Tristan, detectors as H1, Zeus, Venus, Atlas, CMS, or particles like electron, muon, leptons, hadrons, bosons, Higgs, charm, and beauty. So if you look at the naming strategies in particle physics, you can see that some of these names are in the honor of persons like Higgs or boson, or just describing what is there, a large particle, a small particle, or they are joking with words. Some of them are joking with words. It's really obvious that there is something funny about all these names in physics. And Sharon Traweek, in her study on bodies of evidence, law and order, sexy machines, and the erotics of fieldwork among physicists from 1995, wrote, "Making names in this way shows that the groups know how to make the right sort of puns or play on words. What is it about the puns they find so satisfying? Reader, remember that puns bring together meanings which should be kept apart, a kind of verbal incest. These puns directly contradict what all science and engineering students know should be kept apart. What is so important, so dangerous, so illicit that it can only be said in jest, with a joke? Speech and writing, appearance and science, bodies and minds are brought together, all under the name of heroic desire. And I would add it's a heroic heterosexual desire." Female names or illusions of femininity in physics naming practices appear up to now almost in a sexual or sexualized context. They are hardly used to highlight the achievements of women in physics. There are few exceptions. Curie as the non-SI unit of radioactivity, or the Randall-Sundrum model, a mathematical theory for the unification of forces. In addition, physicists should leave behind romantic stories of lonely heroes and devotional love of the 19th century. 21st century physics should represent more up-to-date gender images in their naming practices. In the second part of my presentation, I gave you some examples and research results for what gender studies perspectives can see in physics. Most research is done in the area of people in physics. A lot of research is now done on culture and image of physics, and not so much research you can find on the knowledge production in physics. And now let's come to a brief summary. Gender is a complex theoretical but efficacious concept, limiting the way we understand ourselves and others, and structuring the world, society and culture we live in. Gender and physics are entangled in many ways. We can look at the people in physics, the image and culture of physics, and the knowledge production in physics. There's a lot of research, and still there are a lot of open research questions, and I want to mention only some. How does the social cultural context influence the development of physics in detail? In which research areas? Or how does it influence the models we create in physics? I think that would be an interesting topic to work on. How is gender in physics connected to other categories of social injustice, such as ethnicity, race, religion, or class, to mention but a few? And we call this an intersectional understanding of gender. So gender related to the sex, body, gender system of a society is not the only category, but we have to keep in mind that the person could be discriminated because he is handicapped or black or poor or whatever. So gender is not the only category we should look at. And third, how can the culture and image of physics be developed in a more diverse and welcoming way? So how can we change our understanding of physics and the climate in physics so that it's more diverse and welcoming? So these are interesting research questions. And in case you are working in physics, then we should ask the question, what inspiration can physicists get out of a gender studies perspective? And I think it's good to be a role model or an ally to people of underrepresented groups. Please reflect on exclusions in your work or at your workplace. Leave behind old-fashioned romantic stories of heroes and love, of active men and passive women. Come to more up-to-date stories and narratives. Include more up-to-date gender images in everyday practices in labs and classrooms, in naming practices, in public representations, at conferences, or in your interviews in media. And please reflect on your own advantages. Be open to affirmative action. So, if you are discriminated in one field, for example, as a woman in physics, maybe you are privileged because you're a white person or cis person, a binary person. So, please look at the advantages you have and be open to affirmative actions for the people who don't have these advantages. Thank you for listening to this talk. If you found it helpful or interesting, here are further readings.